Welcome to part 2 of the topic 8A test review. This is covering problems 12 through 20. If you need to see problems from the first page, 1 through 11, please see part 1 of this video. Let's get started. Number 12 says what formula should be used when factoring the expression x cubed plus 64. So, based on my knowledge of perfect cubes, I know that this is a sum of cubes. And so to solve a sum of cubes, I want to use the acronym SOAP. All right. And SOAP stands for same, opposite, always positive. And so looking at these different expressions, I want to look at the signs of these. So I want to start with same. So I want to start with an expression that the first sign is the same, so it is a plus. So this one has a minus, so we know it's not him. This one also has a minus, so we know this one doesn't work either. And so now looking at my next sign, because these two both have a plus right here, I want to look at opposite. So my second sign should be the opposite. So in this case, this one's opposite, this one's opposite. And then my last one should be always positive. Looking at this one, I have that third one that's positive. This one is missing it, so this setup is not correct. So I want answer choice A because it follows SOAP. Looking at 13, it is going to be the same idea. So 2x cubed minus 128. 128 is not a perfect cube, and neither is 2. But if I were to factor out a 2, I would get x cubed minus 64. And we know that those are perfect cubes. This is a difference of cubes, so difference of cubes. But it follows the same pattern. It still follows SOAP. So we want to start with one that has the same sign. So looking here, this one starts with a plus. That's not the same. This one also starts with a plus. That is not the same. So now, next should be opposite. So I have opposite here and I have opposite here. But you notice last time we don't have that third sign. We don't have that always positive. So this is not the correct setup. And we want answer choice D because we have same, opposite, always positive. So we want answer choice D. And then scroll on down. 14 and 15, we are going to actually factor these two. It's asking for the linear and quadratic factors, which we always get at least one linear and one quadratic when we take a sum or difference of cubes. The first thing I want to do is I need to identify a greatest common factor, if there is one. It's the first step of factoring. 3x cubed, I could take out a 3. 375 is also divisible by 3. Now you may not know what that is off the top of your head, but you do have a calculator. You can see 375 divided by 3. I get 125. So if I factor out a 3, I get x cubed plus 125. So x cubed plus 125, that is a sum of cubes. And so to take the cube root of both, I need to identify my a and b. Cube root of x cubed is x. The cube root of 125, if you don't have that memorized, remember you can hit math and then option 4 right here, and you can figure out the cube root of any number. And it is 5, so b is 5. So to follow our pattern to use SOAP like we referenced above, we're first going to put the 3 in front because he is our GCF, so just make him hang out in front. And then it's going to be x, same sign, so plus 5. And then we're going to have a squared, which is x squared. The next sign is opposite, so minus. And then it's AB, so we're going to do 5x. The last sign is always positive. And then b squared, so 5 squared is 25. Now looking at these three, so 3, that is actually a constant factor, so we don't care as much about him. X plus 5 is a linear factor, and x squared minus 5x plus 25 is a quadratic. If you don't remember how to identify these as constant, linear, quadratic, refer to the 8-1 notes where we classify polynomials by degree. Looking at number 15, we're going to do the same process. So first, I have to see if I have a GCF. 2x cubed could be divided by 2. 128 is an even number, so I know for sure it is divisible by 2. So let's factor out a 2. All right, go ahead and write him down here. So 2x cubed divided by 2 will just be x cubed, minus 128 divided by 2 is 64. And so then let's identify a and b. A in this case is x, just like it was last time. Cube root of 64 is 4. Again, do the math in the calculator if you don't remember that off the top of your head. So to write out my factors, we'll put the 2 in front because he's our GCF. And then we want to do the same sign. So the same sign in this case is a minus. So this will be a minus b, so x minus 4. And then next we do a squared, which is x squared. We do the opposite sign, which the opposite of a minus is a plus. And then a times b is 4x. And then my last sign is always positive. And then b squared is 16. So now to classify these, 2 is once again a constant. X minus 4 is linear. X squared plus 4x plus 16 is quadratic. So these are my factors. And again, care more about the linear and quadratic, but the 2 is along for the ride. Now, looking at 16, 17, 18, all of these, this is talking about writing a polynomial in factored form. So we have techniques that we have already learned. We know some stuff about factoring, but for example, this 4-term polynomial, we don't know how to factor him. We didn't discuss factoring a 4-term polynomial by hand. So on some of these, we will just need to refer to our calculator and graph them in the calculator in order to find our factors. On 16, I can do the first step. I can go ahead and take out a GCF. So I can go ahead and factor out x, because all 3 of these have at least one x. So x cubed divided by x is x squared. 2x squared divided by x will be just plus 2x. And then negative 15x divided by x will be minus 15. So I'm going to go ahead. We're going to see if we can factor negative 15 to find a sum of 2. If we can't get a set of whole factors, then we will go to the calculator. So if I'm going to factor negative 15, looking for a sum of 2, 15 goes into 1 and 15, and then 3 and 5. I need one of these to be negative. I want the smaller number to be negative because I'm looking for a positive sum. So 1 and 3. So that would get me 14. Doesn't work. This gets me 2. So this one is actually factorable by hand, but again, you can always double check in the calculator. So this will be x, and then x minus 3, and x plus 5. Looking at 17, it tells us to use graphing because, again, this is a 4-term polynomial. So I'm just going to go to y equals. We're going to go ahead and do x cubed minus 2. Oh, I put him there. I have to get out of the exponent. So 2x squared minus 9x plus 18. We're going to go graph him in the calculator. So looking at this guy, I can either use second trace 2, so I'll do that on one of them. But also, if I can just see on the graph where they're at, it's also okay too. So I'm going to start my left bound and then my right bound. So after I establish my left and right bound, I get a 0 of negative 3. So we can say x equals negative 3, which is not a factor, but we will find the factors in a minute. Then next, this looks like 2 and 3. We'll go ahead and double check. You can either do second trace 2, or if those are zeros at 2 and 3, the y value will be 0. So we can also check our table. And I see that at x equals 2 and x equals 3, y is equal to 0. So that's just another quick trick if you just want to double check a guess that you have. And so I know x is equal to negative 3, and then x is equal to a 2, and x is equal to 3. So to turn these back into factors, we simply move these numbers over to the other side. So instead of x equals negative 3, we add 3 over to the left side, and we get x plus 3. Same thing with the 2 and the 3. These are positive, so we subtract them over. So this is x minus 2 and x minus 3. And those are my 3 factors for this polynomial. 18 is asking us to work a little bit in reverse. So having zeros of negative 4, negative 5, and 4, that means x is equal to negative 4, negative 5, and 4. So to turn those into factors, that would be x plus 4, x plus 5, and x minus 4. So you have one of two options. You can either multiply these 3 together, which we have practiced before, or you can simply graph these in the calculator and see which one gives you these 3 zeros. For the sake of practicing multiplying, I am going to multiply these together, but again, you could put all 4 of these equations in the calculator and check it that way as well. So I'm going to start by doing x plus 4 and x plus 5, multiply those together. So x times x is x squared. X times 5 is plus 5x. 4 times x is plus 4x. And then 4 times 5 is plus 20. Combine my like terms. I get x squared plus 9x plus 20. And I'm going to use the box since this is a larger one. I'm going to do x minus 4. So x times x squared is x cubed. So all 3 of these have x cubed. X squared times negative 4 is negative 4x squared. 9 times x is 9x squared. 9 times negative 4, excuse me, 9 times negative 4 is negative 36x. X times 20 is 20x. And then 20 times negative 4 is negative 80. Now, so when I combine all my like terms, I get x cubed. He's by himself. These two are both x squared, so that will be plus 5x squared. I have 2 x's along my diagonal here, so that will be minus 16x, and then minus 80. And that matches answer choice. If I look here, x cubed plus 5x, so eliminate this one, and this one. What do you know? It is answer choice D. Okay. Moving on to number 19. 19 actually has a typo, so go ahead and cross this out and fix it to x cubed minus 4x squared minus 9x plus 36. Depending on when you downloaded the copy of the review from Canvas, this may or may not be corrected. If you got a paper copy in class, this you do need to fix this. So typing in x cubed minus 4x squared minus 9x plus 36. If we go graph it, oh, I need to fix my window. So my window needs to go back to 10. So I have 3 intersections. So again, you could possibly guesstimate it. If you graph this on Desmos, it will simply tell you these 3 points. But again, we can do second trace 2. I'm going to go find my left bound, go all the way down. A little too far. So if I go to the left, my cursor is right there. And then move to the right, I'm just above it. And so that gets me x equals negative 3. And then again, you can either look at these, or this looks to be about 1, 2, 3, and 4, so you can always double check it in your table. So see if that works, or if they're decimals. Yep, 3 and 4 both equal 0, so we can just say 3 and 4. If you ever try this technique and, say 3 and 4 didn't work, that means you probably have a decimal, and you do need to do the second trace 2 process on those as well. But in this case, it works. So if x equals negative 3, positive 3, and positive 4, I need to move all of those to the same side as x, and I would get x plus 3, x minus 3, and x plus 4. Those are my three factors. 20 will be the same process. We can go ahead, since I see a greatest common factor, we can go ahead and try to factor him. I see that 4x cubed minus 12x squared minus 16x, those all three are divisible by 4, and they're all three divisible by x. So I'm going to go ahead and try to solve him algebraically. So if I factor out a 4x from 4x cubed, I'll get an x squared left over. Negative 12 divided by 4 is negative 3. X squared divided by x is x. Negative 16 divided by 4 is minus 4. X divided by x leaves us with nothing. So this one actually is factorable with ways we already know. So if I look at, if I look for something, factor negative 4, looking for a sum of negative 3, it's either 1 and 4 or 2 and 2. I'm looking for a negative sum, so I'm going to put the negative number on the larger term. And 1 plus negative 4 gets me that negative 3 I'm looking for. So this will be 4x times x minus 1 and x plus 1 and x minus 4 are your factors. So that is going to conclude part 2 of this test review. If you have any questions over any of these concepts, please reach out to your teacher. Otherwise, study well, good luck, and we will see you in class.